Welcome to Papa Junk's shop. Now I've been spending some of my YouTube money for additional things here to make life easier, and I decided that my old antique oscilloscope thing was just a real pain in the butt compared to what's available now. And for what I'm going to use, I think this one will be fine. It's a multimeter and oscilloscope 2-in-1. And I'm a little concerned now because it says professional waveform multimeter. Well, I'm not professional, so maybe I'll have to send it back. I don't know. Let's take a look, see what it looks like. Well, we get some real quality batteries to go in it. And I got a new bracket made for my camera, so maybe it'll be a little better now. You can look straight down on stuff. Well, the case is actually feels pretty decent. Look pretty when they're new, don't they? Won't look pretty for long in here. Well, the leads seem fairly good. Pretty decent point on them. Okay. Let's see what the magnet looks like. No, looks like it's laid out fairly good. Quite a bit of information in there. Let's see, where is the specs? Let's see. Maximum limit. Millivolts DC, 250 volts DC plus AC peak value within 10 seconds. Volts DC, volts ohms cap, 1000 volts DC, AC 750 hertz, 250 volts. Doesn't say, does it? Milliamps, 500 milliamps, and 10 amps on the other one. Okay, so apparently that's like safety information for the voltage stuff. Someplace I thought it told the actual specs. Oh, here it is on the back of the box. Thought I seen it someplace. So we got .400 millivolts to 1000 volts DC, 400 millivolts to 750 AC, DC current, 40 milliamp to 10 amp, AC current 40 milliamp to 10 amp, resistance 400 ohms to 40 megohm scales, capacitance 51.2 nanofarads to 10 microfarads. No, that's not. No, 100 microfarads and then 10 MF. I'm not sure the proper terminology for that. Frequency 5 Hz to 5 megahertz. Open circuit voltage 1.5, 3 AAA batteries. You can save 10 waveforms or 100 data points. Size, duty cycle 100%, continuity, judgment, resistance 50 ohms. Auto sleep after 15 minutes. It's got a 500 milliamp and a 10 amp fuse. Okay, that's the main thing. So let's see how we get batteries in it. Okay, so there's a battery compartment. It's pretty easy to get to. Okay, so there. Oop. Duh. Can put the door back on. There. Okay, so off. There we go. That's not too bad. Oh, well, it's better with that on or off. A little bit off because I see it was glaring. So here's our voltages, or AC voltage setting. Let's plug her in the. Pull these caps off. Let's see. This is common. And this is volts ohm capacity. So my garage power is off of my hybrid solar inverter. So let's see what we got. Oops, gotta take them caps off. $113.7. Seems kind of low, doesn't it? So, I wonder how we get the waveform. So, there we go. So there's my sine wave from my Pow Mister. So these buttons must correspond to there. So let's hit this range button. See what happens. Made it worse, didn't it? Be nice if that was a little bigger. Of course, the guy could look at the manual, I suppose. Maybe this is it. Wow, that's really big now. There we go. Oh. Too big and too small. What am I doing wrong? Gotta look at the manual, he might learn, huh? It's more fun doing it this way though. Okay, so push that again to get it back to the voltmeter. Yep. I got the old fluke right here. Let's see what it says for voltage. stick this one in the now my fluke meter doesn't want to plug in. Let me get something so I can get a good connection. Well, there we go. It says 112.8. So I guess this will off by a whole lot. Let's see if I can get both up at the same time here. Yeah, this has only got doesn't have as many decimals as this one. Let's see. Let's push some buttons here and see what happens. Auto. There, now it says 113.7. So this must be the range that it's using. Okay, that's frequency. 59.9. 49.2%. Back to voltage. Okay, well, see, I'll get comfortable with it eventually. So let's try seeing what we got as far as what I got laying around here. Here's a resistor. Get my leads untangled here. Murphy's. Always busy. Okay, so looks like we got ohms up here. Resistance, it says at the top. And I've got a what? 68 ohm resistor, is that? If I remember my color codes right. .2 it says. So let's see what Mr. Fluke has to say. And Mr. Fluke says .1. So pretty close there. Okay, let's see what else I got laying around here. Okay, here's a little capacitor. 001, is it? I think it says .005. So it shows capacitor in there. It says enough. So I don't know how to switch it. Well, let's just hook it on there and see what happens. It's measuring my fingers. Okay, so select diode. There we go. Continuity. Capacitance. There we go. So it's 0.29. 0.31. So it's 0.005 on the capacitor. Switch over No. Yeah, let me go get electrolytic or two and we'll see how it works on those. Okay, I got a couple more capacitors to play with. This says that these are 0.33. So I switched it back onto the original scale that I had. Well, that would come out 0.322, so it's probably okay within the percentage specs. Okay, so switch it over here to this one. And this is a 6,800 microfarad 35 volt. Let's see what this one tests. I've got nothing. What am I doing right here? Capacity. I'll put her back there and try it on there again. Let's see. No. Max, room, stop, exit, I might have to look at the book, huh? What I'm doing wrong. Got the right leads, don't I? Good, I got the other set sitting here. Wouldn't be the first time I've done that. No, I got the right leads. Well, I got another one here, a great big 34,000 at 40 volts. Doesn't do anything either. Yeah, let me take a quick look in the book. Well, I guess I needed to move the leads into this. It does say right there MF. And it kind of shows on there if you really look at it. So we'll try this 6,800. It says it takes it a long time to stabilize. To be patient. Now this looks like it's showing, well, I guess if you go by that MF it would be 6,330. This is on it, it says 6,800. It is new. I don't know the quality though. Okay, so let's try this great big boy, this 34,000. Apparently it can't measure that high. Or is it going to take a long time? I would say it won't measure it. Okay, so much for that. So let's move things back here and here. And let's take a look at my new power supply on the scope part of it. Let's see. Got it set for 14.4 volts. Yeah, we got 14.4. So gee, it looks flatter than I expected. Expected to see a lot of garbage in there. Not too bad. You guys can see that very well. But it doesn't look too bad. I thought there might be some spikes in there, so let's change the voltage up. So there it's maxed out at 50 volts. Didn't seem to change a lot. You can see a little bit of stuff there, but not bad. Better turn that back down so I don't put it on something for it to see it. Okay, so I don't know, I'm not going to test every little thing. I just thought I'd show you guys my new toy. So we got resistance. And diode test. I don't know if I got a diode laying here. Nah, I don't see one. So, continuity. We already heard the beeper. Yeah, it's a pretty good beeper. See how it goes down on the leads. So it looks like we got about 0.4 ohms on the test leads. So I guess this is going to be my new use it here on the bench kind of a thing. This little girl here was getting pretty rough. Dripped some solder on it the other day. Still works good though, and it's fairly accurate for a cheapie, so I'm thinking this one might go in the truck or the camper, so I always got my fluke for a backup. If I think something's wrong, I go get the fluke and use it to compare. So just thought I'd give you a quick look at the, however you say that thing, LM2020. So wouldn't really call it a review, just a looky-see, and took you along for my first experience with it. So if you enjoyed it, give me a thumbs up. If you haven't subscribed, please do. Thanks for watching. I know it's kind of boring, but we'll see you next time. Well, I brought the new meter in and hooked it up on the Windmill. Now the Windmill is made from a smart drive off wash machine. It's 3-phase. This is looking at one phase of the incoming AC. So we don't have a lot of wind, but it's spinning. So we got 20.9 volts AC. Let's look at the waveform. Okay. So we've got a sine wave. It says 37 hertz. Okay, you can see it speeding up and slowing down. It looks like it's almost getting some square wave look to it. Kind of neat. So I wonder what it looks like on the output side of the rectifier. Let's see here if I can get this clicked on there. There. That's the output side, DC side. Yeah, it's pretty flat. You can see a little movement in there. I mean, there's no filter or nothing on it. It just goes, you know, from there to the batteries. So let's take a look at the water wheel. There's the water wheel. I don't know, there isn't much water, so saying 7 hertz. No volts. Must be it stopped actually. Okay, there we go. Must have got enough to make it spin. So the water wheel isn't even contributing anything. So we don't see any waveform there. It's on the AC side. Okay, well, it's just a quick look at the waveform. Okay, back to the windmill. It's actually producing a little bit now. It looks like it turns into almost like a modified sine wave. Around 50 some hertz. I don't know if you guys will be able to see it or not. Right there's the hertz. Kind of glary, isn't it? Is that better? Yeah, the wind's kicking up a little now. $63 hertz I seen. RMS voltage is 21. Yeah, it's only charging about an amp right now. Now, I don't want to bore you guys too long with this. Kind of interesting though. Just thought I'd give you a quick view of what it looked like. See you next time.